Today's lesson, we're going to talk about functions and mainly domain of a function. We'll talk about range of a function from a graph, but most of the time what we're going to be talking about is how to find the domain given a function in equation form. So first off, what is a function? There's two different definitions we're going to talk about. A relation is just a relationship between quantities, whereas a function has a specific definition. A function is a relation which each input has exactly one output, and you've talked about what a function is a lot in Algebra 2 and so on. So what are we going to talk about with what a function is? We're going to talk about domain and range. Domain is the set of inputs or the x values. Okay, the range is the set of outputs or the y values. There's multiple ways to talk about what a function is. You can do it verbally, numerically, graphically, algebraically. We're going to focus mainly on these two right here. Graphically would be looking at a graph. Algebraically would be looking at an equation. Okay, function notation, you have x, which is your input, that's your domain value, and you have f of x, which is your output, which is your range value. An example, f of x equals 3x minus 4. F of x, if you think about it in terms of just a general equation, that's the same thing as y or your output. This is your function part, the 3x minus 4, that's what where you plug your numbers into. Okay, so those are the definitions we're going to talk about. Which equation represents a function? The easiest way to tell from an equation if something is a function or not is look to see which variable is squared. If your variable x is squared, it's going to be a function. Okay? If your variable y is squared, it's going to be not a function. All right? That's just a quick one. If you're looking at your variables that's squared, if y is ever squared, it's not going to be a function. The reason why, to get y by itself, you have to take the square root, which means positive and negative, which means you're going to have two outputs for each input, which you do not want to have based on the definition of a function. So one of the things we're going to do is look at how to evaluate a function. So we're going to look at a, which is a really basic one. What this says is to take the function h, and instead of x, we're going to place it with negative 4. So what you do is you take your h function, h of x. Notice this x right here has been replaced with negative 4. So what we do is we take our equation, 10 minus 3, but instead of x, we replace it with negative 4. We square it, and then we do order of operations. 10 minus 3 times 16. We square negative 4, and then we get 10 minus 48, which is going to be negative 38. And so that would be your value. You can also think of it as an ordered pair. The x value is negative 4. The y value is negative 38. Remember, a function has an input and an output. The input was negative 4. The output was negative 38. The x value was negative 4. The y value was negative 38. Okay. Domain. Domain is the inputs, the x values. So from a graph, basically what you do is you look at the graph from left to right. So if I look at this graph from left to right, I have to figure out what x values are associated with this graph or this red line up here. So if I look at this, domain is the x values. So what I do is I start at the left-hand side of my graph and I start to trace. Well, I got to figure out where this graph starts on the left-hand side. So if I think about this, these arrows means this graph's going to continue to go up and to the left. So that means that I'm going to start way over here, negative 1 million, negative 2 million, negative 3 million. So it's going to start at negative infinity. Okay? Then what we do is we trace it. Is there ever an x value where this graph does not exist? And remember, x goes from left to right. So as I go to the right, is there ever an x value that is not going to exist? If that's the case, then it goes all the way to positive infinity, and what we do is we put parentheses. This is called interval notation. We use parentheses and we use brackets, and we'll talk about when a parenthesis and when a bracket is used when they come up. We use parentheses to represent approaching but not equal to. You can never reach infinity. Infinity is just a representation of going on forever. You can't actually get to infinity, so you can't reach infinity. The range is the y values. Start at the bottom and work to the top. So if I look at this, if I start way down here, is this graph ever going to exist way down here at negative 1 million? No. Where is the first place it starts? Right here at 0. So the first place it starts is 0, and then as we go up, as this graph goes up, if you trace it on the right side and trace it on the left side, notice what happens is it goes up forever, which means we're going to go up to infinity. Again, we put a parenthesis there because we can never reach infinity. But then I look at this. Is my graph is it touching 0? If it touches 0, we put a bracket. And that means include 0. So if I look at the next one, I have the domain, which is looking like this. Notice how this graph goes off to the left. So the domain would be negative infinity to positive infinity, because a graph never has a spot where it stops left to right. If we trace, it goes, there's never a spot where it's going to stop. Then we look at the range. Is there a range value that doesn't exist? Well, the range, notice this graph hovers above the x-axis, so it is 0 to infinity. Now, some people will put 1 here, but notice this graph goes below y equals 1. So we use 0 because it's going to hover above. It means we can go all the way down to like 1/10th, 1/1,000,000th, 1/1000th, something like that. Okay? And then the last one, the domain, the x values. Where does this graph start at? If I start way over here, is this graph going to ever get way over here on the left-hand side? Nope. What's the first place that it starts at? It starts at 1, 2, 3, 4, 5, 6. So it starts at -6. Then I have to figure out, is it going to be a bracket or a parenthesis on -6? So what I do is I look. Notice this is a closed circle. That means it is included. So I want to put the bracket, parentheses. As my graph goes to the right, is there ever a spot where it is not going to exist to the right? Nope. So it's parentheses. And then we do the same thing for the range. The range, start at the bottom, work to the top. Does the graph ever exist way down here at the bottom? Well, if you look, this graph is continually coming down and to the right. So yes, it will eventually get down to negative infinity, and it will go all the way up to positive 2. It includes positive 2, and it's a parenthesis on negative infinity. And that's how we're going to write domain and range. So now we go to the next ones. Find the domain of the function. Remember what the domain of the function is. It's the inputs, the x values. So what I have to do is I have to look at these two questions here. And I have to ask myself, what could possibly go wrong? Two main things happen in an equation, okay, in a function. You can't divide by 0, okay, and you can't have negatives in an even root, fourth roots, square roots, sixth roots, things like that. So what I do is if I remember these two things, that's what's going to help me. Notice here I have a denominator. So can this denominator be 0? Nope. So what I have to do is I have to figure out how to make this denominator become 0. Why? Because I'm going to get rid of it. So what I do is I set x plus 5 equal to 0, and I get x equals -5. So then what I do is I set up a quick number line. What this does, it gives me my x values. There's 0. -5 would be over here. What this does is this gives me a visual. What I've done here is x cannot equal -5. So I get rid of -5. But what it does is it tells me this can't happen. But is there any x values that can't happen, that doesn't work? Well, the only x value that I can't have is what makes this denominator 0. I can have a negative down here. I can have a positive down here. The only number I can't have is a 0, which means that all of these x values work and all of these x values work. So what are the x values that work? Negative infinity to -5, parenthesis on both of those. Then I put a union symbol to show that there's two parts, parentheses, -5 to infinity. And what this is saying is, since I put parentheses on the -5, every number except for -5 works. And this looks kind of confusing up here. This circle should have went all the way over here closer to -5 to show that all of these numbers work as well. And we're going to skip this one right here. We'll talk about that one when I get back. So then I look at this. State the domain of the function. If I look at A, what do I have here? I don't want zeros in the denominator. So I take the denominator, I set it equal to 0, and I solve. Now I have a nonlinear equation, so I factor out an x, greatest common factor, which says that x is 0 and x is 2. Set x equal to 0, set x minus 2 equal to 0, solve those equations. If you look at a number line, it means that 0 and 2 can't work. So here's 0 on the number line. Here's 2 on the number line. Those two numbers can't work. I'll change colors here just to make it a little easier. 0 can't work, 2 can't work. Anything left of 0 works, anything between 0 and 2 works, anything to the right of 2 works. So my answer would be, for the domain, negative infinity to 0, union 0 to 2, union 2 to infinity. And that's how you do that one. Right? I'm going to bring b down here so I have more room to work. So f of x equals the square root of x plus 6 over 6 plus x. So what I do on this one is, what can I not have in the denominator? 6 plus x. Can't have a negative in the, or 0 in the denominator. So I set it equal to 0 and solve. X is not equal negative 6. So x equals negative 6, so that makes the denominator 0. Okay? But there's another thing that I have to think about. The other thing I have to think about is that x plus 6 in the top, this part right here, what can I not have inside of a square root? I can't have a negative. So what I do is I set up this. I want x plus 6 to be greater than or equal to 0. I can't have negatives. That means I have to have 0 or larger. Solve that equation, which says x has to be greater than or equal to negative 6. So then if I look at that on a number line, negative 6 can't work. And then, so that can't work. X cannot equal negative 6. But then this statement says x is greater than or equal to negative 6. Well, what that means is I want all of these numbers greater than or equal to negative 6. Why? Because that's what makes the square root on the top positive. So then my answer would be negative 6 with a parenthesis all the way to positive infinity, because those are the only numbers that can satisfy the square root and the denominator. If I look at C, okay, C, my numerator, I could care less what my numerator is. My denominator, my x minus 10, has to be greater than or equal to 0. I don't know why I drew the square root. So my x minus 10 has to be greater than or equal to 0. So I make an inequality. Greater than or equal to 0, x has to be greater than or equal to 10. Well, that says if 10's right here on the number line, anything left of it is not good, but anything to the right of it is okay. So what do? Do I include 10 or do I approach 10? Well, this inequality says I can include 10, so I put a bracket on it, and then I make my any domain like that.